easier for you to go through. Yeah, hi. So very good evening, everyone. And here we have the third day of our um, STEM and robotics classes. And especially in this segment, in today's class, I will help you understand the platform, the open source platform, the TinkerCAD itself, and further we will move on to the other platforms which we can able to accommodate in our classroom program. So that is too essential for each and every teacher to have the knowledge of these platforms, because the limitations are not the point of these open source platforms. We can utilize the TinkerCAD platform for so many applications. And earlier on this week itself, I gave the lectures on one of the engineering colleges, that is a Greater Kolkata College of Engineering and Management, on the topic of rapid prototyping. So whenever we are talking about this same subject, right, we are talking about the implementation of robotics and AI into our classes. So first of all, we have, as teachers, we have to understand why the board members are implementing these in our classes. That's a major question, right? What they want to see in the classes and what they envision by implementing these classes in our regular curriculum. The major reason was, like I mentioned before, in earlier times, we used to have the registers to log in the data, like entry time, exit time for each and every faculty members in the school itself. But right now, you are utilizing one of the biometric scanners or some kind of RFID tags to go for the attendance system. So as the things like the technology is proceeding towards to help us in a future aspect, like we are going forward in the direction to innovate something, to build something for ourselves, to make our life easier, we are implementing those things as well in our curriculum, so that our children can able to understand the concept as well as they can go through the practical implementation of those things. So the reason why I am introducing the TinkerCAD platform and why I'm convincing teachers to go for the open source platform, because the open source platform comes without any cost. You don't have to pay anything for them, right? So in future also you can utilize the same to have the proper understanding of these platforms. And many examples like the tutorials and PDFs and so many things are available in the Google search itself, right? So you can find plenty full of guidance on it, but you have to learn the way of execution in our classes. Suppose if you're implementing this and one of these students come to you with the ideas, like if he or she wants to build something out of their ideas. So TinkerCAD platform will help you build those things, like the 3D design itself for further 3D printing. And also it does have the simulation platforms to go for the electronic simulations, in which you can able to see the outcome of the setups, right? Like the if you do have the Arduino and other electronics component in your hand, it is uh, like frequent, like it is 100%. We can say that the students are going to damage those components in between. So to utilize those components effectively or efficiently, we must go through the simulation first. Then only we can able to show our students that this is the way to like connect each and everything in one place. And through this we can able to reduce the wastage of breaking of circuitries, like damaging the parts and so many things. And also tinkercad platform is free to use, so that each and every student can also, from the poor background or from the rich background, they can utilize this platform for their learnings as well. So let me proceed with the tinkercad stuff. So as I already asked in last classes, sign up for the TinkerCAD platform. It is easy to sign up for the TinkerCAD platform. And I will show you, I already shared one of the PDF in which the details are mentioned, but yes, I will share it again with you today. So introducing the open source platform is like the TinkerCAD itself is major things to do in our classroom. They have to understand the concept why we are utilizing these things in our classroom program. So open source means it is free for all peoples, like the mentors, educators, and the student around the. So TinkerCAD, yes, is a cutting-edge open source platform designed to empower creators from novice to experts with a seamless, intuitive experience in CAD, the computer-aided design. So here I would like to mention two of the major things in CAD and CAD related to CAD. So we do have two of these stuff. That is the CAD. The first one is the CAD, and second one we do have is the CAM process. So CAD is all about computer aided design, means by using the help of softwares like the 3D design softwares, if we try to envision something in our computer or perform a simulations or prepare our designs, like how our component or the object will look like after our imagination, we put our imagination into our real-time application, then how it will look like, it can be done using the CAD platform. And CAD is all about computer-aided design. So CAD is all about computer-aided design, and through this design software, we can design our products like the model itself. We often call it as 3D modeling softwares. And apart from the CAD modeling in TinkerCAD, we do have other purposes as well, which we will discuss in our further slides. So basically, these platform offers an extensive array of tools for both 3D modeling and electronic simulation. So TinkerCAD is a user-friendly interface, but if you are looking to go for the higher version of development, then I would prefer you to go for the design softwares like the SolidWorks, AutoCAD, and there are many of these design software available in the market to develop the prototype in the design phase. So we can start with the TinkerCAD platform for now, because it is hard for the educator to have the proper course on SolidWorks and other designing softwares for the same. So TinkerCAD has become a go-to choice for educators, students, hobbyists, and professionals seeking to explore the world of digital design and innovation. So apart from the CAD, what we do have is the CAM stuff, right? Maybe you already heard of the CAM. So may you please help me? Have you ever heard the CAM before, or this is the first time you are hearing from the CAM feature itself?
Heard of it before.
Okay. So anyone of you? No? So the reason why I'm asking you to actively participate.
It is nothing but the computer aided manufacturing. Am I right?
Yes, that's perfect answer.
Yeah, manufacturing.
Thanks for your support. So actually, the CAM stands for computer aided manufacturing. And why I'm mentioning this term in our TinkerCAD journey, because many more companies will let you understand the concept of TinkerCAD, but they won't help you to understand why we need those in our school itself. So computer-aided manufacturing become a vital things in our in our industry itself. It gives us the flexibility to utilize the 3D design models directly into our machine system, so that we can able to manufacture those directly by controlling through the computers. So you may also heard of CNC machines, computer numerical control machine, which can be controlled using the CAM software. So through that CAM software, we can able to produce any of the product out from the designed model. So CAM is useful in many industry. And why we are discussing about CAM? Because we are utilizing the TinkerCAD platform for two of the application. First, we will go for the 3D modeling, and further how we can able to utilize the 3D model in our project development. So we will have a thing called the rapid prototype. You may already heard of these things before, like the rapid prototyping. But let me tell you, rapid prototyping is all about 3D printing. So suppose if you do have any idea, you just have to go for the 3D modeling stuff. Then further, you will process that 3D model using the 3D printing machines. So it will be helpful for you to help your fellow students to develop the project in deeper sense, and also it will allow a window to go further beyond the innovation itself. So you are actually creating something new out of scratch, right? So we will utilize those things as well in our day-to-day journey in our STEM career. So TinkerCAD platform, we can utilize TinkerCAD platform for several things. First one is the education. So we can able to go for the TinkerCAD platform from the electronics 3D designs, engineering, and so many things. So it is basically used for different by the different designers and engineers to develop the prototype. And as the name implies, prototype is all about developing something from the scratch. Right? So product design is another aspect for the TinkerCAD platform. So from consumer goods to industrial machinery, TinkerCAD assists conceptualizing, refining, and visual product design. It's also capabilities enables designer to create detailed 3D model of their product. So why I'm trying to mention these terms to you, because suppose if you have to build something, like you are participating, your student is participating in one of the competition, like whether it is the national level competition or the international level competition, and he or she does have the idea of one of the project, like the cube itself. Suppose, for example, we are taking these cube as their ideas, right? So what will happen if you go for the production phase for these particular product? Then what will happen? You have to prepare the mold design, and further, it will cost you to 5 to 6 lakh to have the mold design in your hand, and then only you can able to see the final product in your hand. But rapid prototyping gives us the flexibility to have those prototyping functionality without investing much more money to the mold system and regular core and cavity kind of stuff. So that is why we are into the rapid prototyping using the design softwares and 3D printers itself. So
Please, ওদেরকে
yeah,
phone
sorry.
কর।
Okay, please mute yourself if you're talking to someone else. Sorry for that. Thanks. So the application of TinkerCAD platform is the 3D printing, electronic simulations, architecture and interior design. So you can go for the architecture and interior design as well using the TinkerCAD platform by creating 3D models of building, spaces, interiors, and it aids in visualizing layout. Suppose if you have to design the complete layout for your home itself, then we can utilize these platforms as well. And for the electronic simulation, as I mentioned, you must go through the electronic simulation in the TinkerCAD platform first, so that there will be less chances of like a making your device won't work at the some point of time. So it will be great to start with the simulation, then go for the hands-on type of stuff with yourself. So apart from these, the 3D printing and all, what we do have is the game design. Yes, it is based on the scratch programming itself, the TinkerCAD platform. So we can able to develop some of the games using the 3D assets created in TinkerCAD platform, characters and environments for video games, interactive experience and virtual reality applications. If we get more time apart from the 10 days of our classroom program, then I will help you understand how we can able to design 3D assets, character, video and environments for the video games. And further, we will utilize the Python programming to combine each and everything in one place and have our fully functional game to showcase in front of our students. And apart from the game design, what we do have is the art and creativity, the DIY projects, and collaboration and sharing. Yes, as I already shared one of the link in my last classes to and ask the teachers to join over that link. So it will be great if you can join over to the same link, so that we will be in same place and we can share our designs with each other, right? That is the reason I created this series of this lecture to get.
Sourbh ji, I think I missed it. Is it possible for you to resend it in this particular chat itself?
Yeah, sure,
Sorry
ma'am.
about it.
No problem. The reason why I created this class is because, see, I'm not saying I'm perfect in all sense, but what I can do for my country and for the teacher out there is to help them understand at least the basics, so that they can start these things in their classes, in their school, right? And after that, in future, yes, if you do find any of the good ideas or any good project, if you do have, then yes, Saurabh Kumar will be there to accept those from you and can able to do in my school as well. That is why this is the reason why we are having the groups and all, right? So collaboration and sharing is also the major thing in TinkerCAD platform. We can add more collaborators to work on single projects. Suppose if you're facing some of the issue in design or the simulation stuff, then you can just share those design with me or other fellow teachers and the person who is professionally good in those platforms, so that they can fix the problem and help you in no time. That is the major advantage of TinkerCAD platform. And as I already shown you earlier, we do have a very simpler interface of 3D design platform, right? We do have the work plane in here, and as all the software does have the things like the menu bar on the top, and sub menu bar does contain some of the tools in here, and we do have the viewport in here. And apart from the viewport, we do have zoom in functionality in here and zoom out functionality in here. These old terms are mentioned in my PDF, which I shared to you guys earlier. And I believe today also I will share again those PDFs to you. So we do have the SIPs segment in here. So through the SIP segment, we can able to just bring out those structures which is already predefined in here, and using the logical conclusion, right? Suppose if we do have the cube-like of structure, we just imported the cube-like structure in our design, and if we try to merge this cylindrical object in between, and there is two type of object in the TinkerCAD platform. One is solid, and other one is uh, we can say that hollow, or we can say that it is a whole feature of the TinkerCAD platform. So we do have solid object, we do have hollow object. Suppose if I'm putting the hollow object inside of the TinkerCAD platform, then what will happen? It will create the depth in the previously imported object itself. So this is how we can go through the basics of TinkerCAD, and in a minute I will show you how to like go for the TinkerCAD and other stuff. So in a meantime, how we can utilize the 3D printing and the TinkerCAD platform, we can able to design many things as we think of using the TinkerCAD platform. There is no limitation on that. You can see the high quality design were created by several designers around the world. And also on the right hand side, you can see a 3D printed castle planted. So these castles are good in look, and some of the innovation also involved in this thing, because the creator will think of the like how we can able to change our way of plantation in our home itself, right? So if by using the creativity and the creative things in our home, we can able to develop those environments around our kids to help them understand the importance of the more creative outcomes of these platforms. So one of the chat is mentioning, may I know what are qubits? Okay, I will let you know what is qubit, but today we are into the TinkerCAD platform. So let me summarize those first, and I will come back to you at the end of the study. So allow me to share my screen of the TinkerCAD platform itself, so that it will be great for you to understand the terms of the TinkerCAD platform. So the time when you log into your dashboard, you will see these options, right? These options. My screen is visible to all of you, right?
Yes.
So I already created one group, STEM and Robotics AI classes for teacher. I'm again going to share this link with you all beautiful minds out there, so that it will be great to have each and every teacher in one place, so that I can also share my designs with you, and you guys will create some of the good design. And yes, I will love to print those in my 3D printing system. So yes. So first of all, you just land on these dashboard, right? And after landing on this dashboard, you just have to click on the design, and you will find one button mentioned in here, like the create below the your designs, the text below designs, right? You just have to click on create, and you will find three of the options to start with, right? As I'm going to explain the 3D design feature in TinkerCAD platform, so I will choose the 3D design. But apart from the 3D design, we will further have the circuit development using the TinkerCAD platform. And after the circuit development, we will use the code blocks as well as embedded C++ programming in this platform, so that it will be great for you to understand the whole concept of design features along with the circuitry development plus programming itself. So I'm just going to click on the 3D design. So after clicking on the 3D design, you will land on this page, and you will find one like a random generated text on the top of these things, right? So I hope my screen is completely visible and you can able to see the name on the top of the thing. So we just have to change the name as per your convenience. Otherwise, you can keep it as it is. The reason why I'm asking you to change the name, because it will be great for you to keep track of your designs. So I'm going to write that this is my first design for teachers, right? Teachers training. So it will be great for us to remember the same, right? So now the name is changed, and below the name you can find plentiful of tools, right? Three or in total 6 tools are there. One is for the copy. So if you have object in your design in your, just allow me a second, please. Okay. So if you do have the one of the object drag and drop, just you need to drag and drop the object in the work plane, then you can able to create several copies of this object and paste it according to your need. So right now we are just created one another copy of this object. So this is how we can able to copy and paste the object in the work. So this is our work plane, and using the mouse, I prefer you to go for the mouse, using of mouse in this platform. Otherwise, it will be difficult for you guys to keep track of the points, as it requires a precision to handle those stuff, like the design stuff in this platform. So let me connect my mouse first. So now we do have the viewport in here, in which top and front is mentioned. And you know there are several viewports to look after. We do have, if we take example of any of the cube structure, so we do have front face, back face, left side view, right side view, top side view, and bottom side of view. So there are 6 type of view, as well as apart from these views, we can able to project it isometrically. Isometrically means the 3 of the sides can be visible at a single time. So this is the benefit of these viewports. So we can um, see the different sides, like how the how object will look like from different side. We can able to see using the viewport itself. Apart from the viewport, we do have the home view button. So it will summarize each and every design in single screen itself. And specifically, we do have fit all in view. Fit all in view, as the work plane is too vast, in which we can create several of the models at a single time, so that if we have to look for each and every model present in our work plane, then we just have to click on the fit all in view. So we do have zoom in button, that is the plus symbol on the left hand side, and we do have the negative symbol, the minus symbol, for zoom out. And apart from the zoom out, we do have the orthographic projection in here. And orthographic projection is similar to the isometric projection, but the angles between the planes is something different. And you can also able to see the 3 sides of your design part in through this button. So on the right hand side, we do have the tool menu. Tool menu consists of, just long a second, I need. Yeah. So this is all about the thing. Okay, sorry. Yeah, I'm just dragging the video from the right hand to left hand side so that it will be visible to me. Otherwise, I cannot able to see the tools menu. So now we do have is the basic shapes. In the tool menu, we do have the basic shapes. If you click on the basic shapes, you will find plentiful of things are already mentioned in these things, right? You can insert each and everything from these places, and you can utilize it on your like design stuff and design classes. So why to have these shapes, like the basic shapes, designer, starter, creature, and characters? Because the TinkerCAD platform, the developer of TinkerCAD platform already gave us the versatility or the benefits by adding these predefined components in our design section. So suppose if we have to bring some of the nut and bolts or some of the electronic parts in our design, so we don't have to design it from the scratch. We can utilize the predefined shapes from the gallery itself. So I'm just using the basic shapes for today. So you can see there is a a bunch of different shapes present in this segment, right? In this section. And there is one difference between the two things, like the cube itself. If we see, this one is the box shape, and apart from this box shape, this one is also the box shape. Then what is the difference between two? If we drag and drop the box shape in our work plane, then we can see this particular box is solid in nature, right? This particular box is solid in nature. And if we click on this box, you will get the property. If you click on any of your solid models, you will get the chance to see the properties of the shape itself. So right now we do have two of the option popping out after clicking on the box itself, that says solid or whole. So solid means it is the solid body, and if we click on the solid, you will be given by the options of changing the color of this body, as well as you can also change the transparency to look from different perspective, like you can able to see through the object itself. So these are only for representation of your design, and not, it will not cause any problem while doing the 3D printing of these models. So you can also remove the transparent, and also you can choose the multicolor option. If you do have any custom range to choose from, you can able to go for the custom and change the color accordingly to each and every product you see in the screen itself. So whole feature enables it to make it as a whole. Means if we try, like, remember the mathematical concept in from our classroom program. If we do have two of the numbers and if we try to subtract it, then what happens is we left with the remaining portion of it, right? Suppose if we are subtracting 16 out of 8 out of 4, or 4 out of 8, then we will have the 4 in remaining in our hand. So if we subtract two of the models or two of the shapes, basic shapes, then what will happen? It will remove the like uh, intersecting part from the model itself. So we can able to improve the radius of this object, and increasing the radius means we are providing the round corners for this object. Means earlier it was the perfect cuboid structure, but as we increase the radius, it will give more fillets and jump fillets in this, in the corner side of the edges, on the edges. And also we do have various settings to increase the length, width, and height, but I won't ask you to go for changing the length, width, and height from in here, because you will have the functionality by, you can able to utilize the functionality by directly clicking on the white dots. You can see there are plenty full of white dots and the black dots, right? You can find two black dots. Black dots are there with different shape, and the reason why we do have black dots in different shape, I will just explain. I'm going to explain that in a few minutes. So the black dots help you to pull and push the sides, so that you can able to increase or decrease the length or width of the object. As well as if you click on the white dot, then you will be given by the options to change the dimension. Here we do have length 31.12 and width is 24 dot dot. So this is basically in mm, so we are following the system in here. So I'm just going to change it at the value of 30, and again I'm changing the value of width to 30, so that it will perfectly on that sense. But one thing is missing from this thing, it is not, it's still the perfect cuboid, right? Because we need to have the proper height as well. So if we look into this above dot, the white dot on top, if we click on this white dot, you will again sorry, you will again get the same features to change the dimension. So again I'm clicking on inserting the value of 30 and just hitting the enter. So hitting the enter, now my object is perfectly uh, like the shape of this object is perfectly cuboid, and each and every side does have the same length, the 30 itself. So this is the way we can able to change the dimension, and I already explained why the white dots and black dots are there. So black dots, even though after changing the dimension, if you pull and push the black dot, it will change its shape. But I would request you all to change the dimension by clicking on the white dots, as it will help you to get exact measurement of the sides of your 3D design. So suppose by mistake we done this, and if we want to change the length value back to 30, to do so, we do have two options. First one, we do have one of the buttons on top of the screen, that is the undo and redo. Redo is to redo the stuff. So controls X, control Z will also work in this thing, as we do have in our Microsoft Office and other software. So we can utilize the control Z feature to reverse the action, what we done in our design section. So why we do have these holes, let me explain you in a deeper sense. Suppose if you want to drill something, or you want to cut out the portion in mid between, so either you want to bring the cylindrical outcome, like if you have to make this cylindrical shapes, cylindrical cut in the middle portion, then you just have to drag drop the feature. Right now we dragged and dropped the cylindrical hole in the segment. Let me see. Okay. I'm just dragging and dropping the cylindrical stuff on here, and the time when you will drag and drop this component, it will stay on top of it. If you lift and try to move this object from one place to another, it will follow the same work plane. You can see there is difference between two work planes, right? We just drag one of the component on top of it, so it will follow the another work plane. So it will stay on top each and every time. So suppose if we have to change the work plane to this one, to the bottom one, we do have the blue one, then what we can do, we just have to click on the object, and here it comes the uses of the triangular black dot on top of the object. So we just have to drag and drop, and it will give you the height sense, like how the height is changing. It will reflect directly in your design. So you just have to make sure that you are, if you are changing the work plane, then you should go for the 0, 0 dimension. So it will stay on the blue side. So now we change the work plane for the second shape in our work plane, and you can see the second shape is perfectly lying on the same plane as we do have the cuboid shape in place. So if we need to change the height, we just have to click on the white dot on top of it, and we can just drag and drop to change the height of this shape. Otherwise, we can just simply put the value of how much height we want for this shape. So we just inserted the 40 mm height of this shape, right? So if we have to make cut, like this feature is the whole feature which we are utilizing. And why to have the whole feature in our design itself? Because if we drag and drop this thing inside of this cube, and we try to select both of the things, and how you can select both of the things at a single time, you can just click on the left mouse button and you can select it like this. So both of the models will be selected. Otherwise, you can just click Control A to select both of the models, but it is not advisable, because right now we do have only two components in the work plane, right? Two of the shapes in our work plane. But in future, if you do have 3, 4, 5, 6, like this one, if I'm dragging and dropping each and every shape in the work plane, and now if I click on Control A, then each and every model will be get selected. So you have to make sure that the desired models, the desired shape will be selected in single time. So you just have to click on first model, or otherwise hold the shift button in your keyboard and click on first model and second model. So both model can be selected by this way, by this shortcut. So it will be easier for you to choose two or more as per your requirement. Choose the object as per your requirement to do the remaining operations. Why I selected these tools? To help you understand the concept of remaining toolbar on the top. You can see one of the feature is there on the top, that is the align, because you want to drill something down the center of that particular object, then how you can able to align centrically. So we will use the align tool. The time when you click on the align tool, you will given by the option of these dots, right? If you hover through the dots, you can see there is the option. These dots will help the object to stay on top of it, and these option will make the object go and align itself in the middle plane, right? And also similar thing happens with these dot as well. So if you have to align on the x-axis, we will click on the middle dots on the x-axis, and if we have to align on the y-axis, then yes, we will click on the middle dot of y-axis. And further, if we have to align the dots on middle axis of JAD, then we can able to do that. You can see the object change the orientation, right? Change its place for the drill to happen. So we are utilizing the bottom one in here. We are going to utilize the bottom one in here, and we aligned it perfectly. Right? The model is now aligned, and the black dot turned the gray one, as it is saying that we aligned the two objects according to our need. Like the gray dot is representation of how we are aligning our object in the plane itself. So now my object is perfectly aligned, and you can see from the uh, top hand side view, you can see clearly how our model is aligned perfectly in the center of this cuboid structure. Or either way, you just have to click on top button in here, and you will be redirected to the top side view of this object. This is the simplest way to drag each and every viewport, so that you can look after the different components in place, as well as you can utilize the viewport as per your need to see the object from each and every side. Either you can do one more thing to like what I'm doing in the screen itself. You just have to click the right side button of the mouse itself. Just click on it and keep it clicked, and just hover the mouse here and there, so that you can able to change the viewport as well as the orientation of the view angle on your screen itself. So now our object is properly aligned, but these are still showing as two different objects, right? One is the whole feature, and another one, the cuboid, is in solid feature. So how we can able to subtract these to form a definite shape, that is the drilled shape in our cuboid structure. So we will again click on the whole feature, then press the shift button, and again click on the cuboid structure, then two shapes. Like you can see here, shapes bracket 2 is mentioned, means two of the shapes is selected, and we can find one of the options just glowed out, right? The group function. So if we click on the group function, we can able to do one thing. After clicking on the group function, it will do, it will delete all the whole thing from the object itself. So we are trying to merge two of the positive and negatives together. Then at the end, what we will left with, the remaining values, right? So the cuboid structure, which is not intersecting with the whole structure, will be left in our work plane, and the intersecting thing will be removed from the screen itself. So you can see this is how you can implement the whole kind of stuff in the design, in the work plane and your design. So these components which we brought into our segment, like in our work plane, you can also change this object from solid to whole, so that you can utilize the other whole kind of features. Suppose if we have to like drill this particular thing, like we have to make this slot in the side of the cube, then we just have to click and press shift and select both of the components, and again group the components. So you can see now we implemented the pentagon type of two of the sides were cutted off from the design itself, right? So this is how we can able to cut groups and different notches. We can able to make segments and do the things. So if we okay, TinkerCAD platform does utilizes a huge size of internet connectivity. So make sure you do have a good internet connectivity while using the TinkerCAD platform. Otherwise, everything will be stuck on the screen itself. So now we do have, we removed the one or two of the portion, that is the circular portion or the cylindrical portion on from the middle of these. And we also removed the polygon shape from the side of it. Suppose if we don't want to don't want these things to be happen to this component, we don't have any redo or undo button because we already made several or like 10 of the changes, and we don't want the first change. Then what we will do, we will just click on this object itself, and here we do have another option on the top of the tool menu, that is the ungroup feature. You just have to click on the ungroup feature, and you can see this particular shape is ungrouped from the object itself. Then again, we will click on the object, click again on the ungroup feature. Then we can able to separate out those features which we grouped earlier, right? So this is how you can able to undo and redo the things you have done to your design, and you can able to change the design accordingly. And if you have to do the grouping feature, or you have to subtract out the things from the center of this object or from the side of the object all together at a single time, then you just have to press the shift button and select all the um, three shapes in the design, in the work plane itself, and click on group button. So at once we can able to implement the same grouping and cutting features. So it will be helpful for you to utilize these tools to help you understand the thing. So apart from these things, what we do have one more thing in our tool menu, that is the toggle nodes visibility. So by clicking on the toggle node visibility, just click on the toggle node visibility, you can able to keep the nodes in here. So right now the feature is not visible. Just click on it. Okay, I will explain these nodes feature later on. So first, let me drag and drop different stuff to do the experiment with the TinkerCAD simulation. TinkerCAD designing stuff. So we just have to change the drag and drop the object from one place to another to make some spaces for this same. So we can also drag and drop the text feature, and by dragging and drop and clicking on the text button, you can see you can able to change the text from here. So I'm changing the text from text to stem. So stem will be shown in here. But if you have to go for the 3D printing of these things, then you have to correlate each and every letters in one place, because otherwise what will happen, printer will print this as TEM separately, right? So you have to merge all the things together. So for that reason, I'm going to use the basic save feature, that is our block, and just dragging the block in here. I'm just the increasing the length and reducing the height for this. And again, I'm trying to adjust it in one place. So I'm just rotating my view to make me comfortable with the environment and to utilize the proper outcome of this platform with ease. So that it is important for you as well to rotate the views again and again to see the orientation and how the thing is going on with the design itself. So it will be helpful for you to carry out different designing lessons in your classroom program. So now, right now, the two things are different. Right? These two objects are the separate one. These two does have the different properties. So combining those two solid objects also result in one single object. So if we try to group these two things, then it will become one. See, earlier it can be selected. We can able to select the two of the design separately, but now we can able to select these tools at the single go. So this is how you can able to design the stuff in TinkerCAD platform. And as well as you do have various shapes and structure to like go for the designing. You can tweak and twist the thing to see the outcome of whole designing process. So you can utilize and drag and drop different things on top of it. Then it will give you the respective outcome for your design journey. So suppose if we have to drag and drop something on top of this cuboid structure, and if you just drag and drop these cone shape structure, like I dragged and dropped this cone, this rocket nose kind of shape. So if we try to lift this thing up on the top, it won't be, we will not be able to like do that, because it is fixed in this particular blue work plane, right? So to do that, I mentioned the one thing, just try to drag and drop this component inside of the object, like here, and here you will find the arrow button on top of it. Just try to lift this up and change the working plane. So changing the working plane like this will be difficult for you to like have, because we have to carefully go down and adjust the place, right? The dimension is 30, then yes, we can able to change the dimension from in here, the 30. Then only it will be stay on this particular plane, and we just have to drag and drop this on the middle of it so that it will stay on top of it, right? But to do that professionally, And again, if you try to drag and drop this object, it will follow the same plane in which we asked it to do is to go, right? The same work plane. It won't come down until and unless if you click on the same triangular arrow button, the black one, and drag and drop to the lower plane. So to remove the like the problems, like to face to change our this viewport stuff and to professionally import something into our work plane, you just have to follow the basic procedure. The time when you drag and drop some of the structure from the shape library, you don't have to leave it like that. You just have to come in front of these device, and the time when you will hover through the shape, you will find plenty full of tracking of different surfaces. So if we have to drag and drop this object in this surface, we simply leave that on this surface, so that it will create another work plane with respect to this side as well. So we can able to create this, as well as if we try to drag and drop on top of it, we can able to do that as well. So right now it is not aligned. These two are not aligned. We can able to alignment procedure by following the same method, by clicking the two of the things and aligning the same. So what we are trying to do is to drag and drop the same structure on center, and in here, so you will find the different option in here, and again just lifting this object on top of it. So aligning is little bit difficult, so that try to let your object come to the particular place, like in mid between but not approximately correct. Then select the two of the object and click on the align button. Then you can able to align this object perfectly in all of these things. So now you can see it is perfectly aligned with the center of the cuboid structure. This is how we can able to drag and drop different shapes in the work plane itself, and we can utilize several of the design features like the basic shapes. And apart from the basic shapes, we do have different creatures and characters to have the same uh, design understanding for our students. So we can able to drag and drop different shapes and creatures, as well as we can also able to develop some of the electronic circuitry. Suppose if you're explaining uh, the Arduino board itself, then it will be a great for you to use these kind of model to showcase the 3D version of the board itself. And we do have dry cells and other things are there. If you click on more shapes, you will get plenty full of electronic device, which we are going to utilize in our electronics journey while having the electronic classes for the robotics. So these are the servo motors, as well as we do have the solar panel, the LEDs, and the microbit itself, the greatest microcontroller of all. It is far better than the Arduino platform, but yes, the price of Arduino is comparatively low. That is why we are utilizing the Arduino in our application. And otherwise, there is no certain things to carry forward in our robotics classes. We do have hardware stuff as well in this segment. So gears and basic mechanical structures are mentioned. If you click on more shapes, you will find plenty full of examples of shapes in this in the design shape section. So apart from these, we do have everyday object as well, like the laptop or mobile phone and other accessories. So you can utilize those pre-built design into your work plane, so that you don't have to design it from the scratch. Yeah, and this scratch means you don't have to start from the 0 point, as you can able to drag and drop these kind of multiple objects while doing the designing work in TinkerCAD platform. And apart from the designing stuff, we do have the SIMS lab, which I'm going to explain in our next classes or other classes. The SIMS lab is very much important, because if we have to create some of the simulation, then we can able to utilize the sim lab for the same. You can see some of the basic things like some of the random animation is happening, but we can able to address those things by setting the scenes and changing the settings for the same. We can able to animate these stuff. Suppose if we want our robotic body to walk from this place to that place, we can able to perform the simulation using this Sims lab. As well as the concept of physics can be taught using this Sim lab platform. We can able to create the roll down effect and something like that to have the same for the visual perception. And also, if you'd like to drag and drop, like many components are already drag and drop, let me delete some of the components. If you have to delete the component, you just utilize the delete button in your keyboard by clicking on the object itself. Otherwise, we do have one delete option on the top of the tool menu. You can see delete option on top of the tool menu. So just click on the delete button, and then you can able to remove the object from the workbench. So I'm removing the maximum number of components so that our workplane will be free from everything. So now I'm dragging and dropping the object from the workplane. Suppose by any chance you cannot able to I'm going for the basic steps. You cannot able to place this slender on top of these, and you have to face the limitation on that. So we do have the workplane tool as well. Just click on this object and workplane tool, and just dragging and dropping the workplane on this one will give you a a range to have the workplane in this one. The another workplane we just created for other components to drag to place on top of it. So these two workplane will help you to like design on certain sides of the object. And if you drag and drop now, then you can see you will given by the two options. First one is this one, the orange one, and second one is the blue one. Right now, my screen is not properly showing the blue one. Let me just zoom in. You can see you will get two of the options. Okay. Let me drag and drop. See, this base is showing blue. That means the blue, the bottom workplane is active now. And if you change it to the top, you can see the top workplane is showing in orange, right? So you can see the difference. Here it is completely visible to you. You can see the difference. If we drop this object right now, means it will land on the bottom workbench. Let me show you. It will land on the bottom. Sorry, I left it on the top of it. So if we drag and drop these in here, it will land on the top. And if we try to remove this one and bring the component in here, it won't be possible because workplane is empty. Let me remove the workplane first. So now I remove the workplane, and now you do have the opportunity to place the object in the bottom workplane. So you just have to click on the workplane for one thing, and again click on the workplane to remove the workplane for the same. Right? You can able to do that for rest of the object, and you can um, indirectly import the object in the specified plane itself. So to align this thing again in center of it, just try to come up with the minor adjustment and then select both of the object at once by hitting the shift button on your keyboard and click on the align button, and you will see the plentiful of options to like align this object in between. So you will find the option in here. So it is already aligned actually. So that is why the gray dots, it does have the gray dots because it is aligned perfectly, and you can see the center line, and which is the proper representation of these two object is aligned properly in the center itself. So if the center line lies, like if we do have two center lines for this object, then we can say that the object is not perfectly aligned by any time. So if we change the center line now, if we click on the on these, and you can see the changes of center line. If you click on the cubical structure, you can see the center line is in here, and if you click on this structure, the center line is in here. So to align it perfectly, you just have to click on both and click on the align, and you will find it is aligned perfectly, right? So this is how we can able to change our shapes, direction, and workplane to perform different operations in 3D design using the TinkerCAD platform. And try to rename. I will create the activities in my sheet so that it will be great for you to join over on those activities and create some cool stuff in your designing, in this designing platform. So as far now, any doubts from your side, teachers and other members?
I
As of now,
think we
if
will
you do
get
have
more
any
questions when we do it hands-on.
Yeah, that will comes to your mind after doing the hands-on using this platform. Yes, ma'am, that's correct. So I would like to limit myself today for these introduction. Then only you can able to go through the complete shapes and different things. At the time, I will just drop the PDF design because I thought to share these with you during my classroom in which each and every details are mentioned properly. As I already shared this with all of you.
Sir, one question. How
Yeah.
will designing the project help us in our 3D thing? It's mainly. How is this going to help us, sir, design?
Uh, I do not understood the question, ma'am. Can you please
So now
rephrase
you
it?
taught us how to design the project objects, like, okay,
Yeah.
take something and design. So how is it going to help us in future, like in future classes?
Yeah.
I
So
thought the
many of
design
the
was
things.
mainly, 1 minute, sir. I thought the design was mainly um, designing circuits and everything. So how will this help us?
TinkerCAD platform gives you the ability to design the things from scratch, right? And why? What is the reason of that? Because earlier I also mentioned that I uh, myself not involved in the process of DIY stuff, right? I'm not. I do not believe in DIY stuff to teach to our students. That is why I create my own model to teach them how to like design this stuff using the TinkerCAD platform. You utilize the 3D printing technology to print those and build the component out of scratch. So these models which I developed earlier was the development through the TinkerCAD designing platform itself. Then only we can able to see the complete project in our hand using this platform. And the small robots, like I asked you to buy the components from the market, right, ma'am? So you can able to buy these servo motors and so many things to build robots, small robots and different projects on your own. I will share the design files of my projects as well in future classes so that it will be easier for you to acquire those and print those in your students. So these things, the designing itself will help the student to build the project from scratch so that they will have the understanding of how these things came to the existence and how we are developing projects for our uses.
Okay, fine. Thank you, sir.
Yeah. So I will share this complete tutorial PDF again with you all teacher in the group itself. So it does have the proper way of explaining how to sign up for the TinkerCAD platform, and different tools are mentioned properly in here with details for each and everything like group, which I already explained in my classroom, the group feature on group feature. I just left the flip feature, which I will explain in further classes when we will design something great in TinkerCAD platform. So using the right click scroll and the left click is also properly mentioned. Apart from these, we do have the navigation stuff and the proper viewport settings like the word plane is also mentioned. And you will see plenty of the tools and the details mentioned. So I will request you, all of the teachers, to go through this PDF and start tinkering of 3D design by today and tomorrow itself so that you will get a proper expertise in designing stuff in TinkerCAD platform. Design, the main reason to have the understanding of the design feature, because at some of the points you need to create some of the prototypes. Like in DPS, last week we had one of the competition in which the student designed the system to self water the plant. To self water the plant, they utilize the Arduino and different pair of sensors. But to accommodate those things into one body, like I mentioned during my first few basic classes of robotics, like we do require one of the outer casing for the robot to accommodate each and every electronic parts, right? The electronic parts mean the motors and sensors, the output device, the brain of robotics. So we need the chassis for the application. So this platform will help you build the chassis as per your convenience, as per your requirement, rather than you build the circuitry and you have to move from one place to another to find out the proper uh, box for that project. So you don't have to worry about those as well, as we do have the rapid prototyping stuff like the 3D printing machine does comes in very low cost, and you can buy those as well from the market for your school, not for your personal benefit, for this school itself. So, going through this lesson, ma'am, you can able to learn the different methods we can able to utilize in the TinkerCAD designing platform. And the time you will complete these complete lessons in the TinkerCAD platform, you will get the proper expertise to create any of the object, and whatever the things you will see in your regular day-to-day life, you can able to perform those in the simulation and 3D designing platform itself. So this is why the 3D design is important for all of us. So as a teacher, we need to have those things, those capabilities in our side. Otherwise, it will be difficult for us to guide the student properly in each and every segment. So I request you all to join over the classroom I created for the TinkerCAD platform for each and every
Sourbh, can you show how to rotate an object?
Yeah, absolutely. So we do have these thing. So here we do have the object which we created earlier. The time when you click on the object, apart from the white dots and black dots, you will see one round kind of angle kind of stuff. Angular two dots are there. So it will give you the sense to rotate this object on the specific axis. Like we do have three of the axes, X, Y, and Z. Suppose if we want to rotate this object from the axis for the Z axis itself. So we just have to click on these, and then we just have to drag and drop the object from one place to another. Otherwise, you just have to click on the angle and click on the angle button itself. You can able to change the angle to your design, like 90 degree. Rotated this object 90 degree as per my guidance. So here you will have the same feature on other side as well. If you click on the object again, you can able to see these things, like three of the rotation tools are mentioned. If you hover through it, you can able to see the angle is properly mentioned, and you just have to click once on this arrow, and the time you will click on this option of changing the angle of rotation will be shown to you, and you just have to insert the desired angle of your rotation and hit enter. It will change its orientation as per your need. This is basically how we can able to rotate the object in the work plane itself. And if you have to drag and drop the object in work plane from any point of space, you just have to click on the object. Try not to touch the white and black dots. Otherwise, what will happen? The white dots is responsible to increase the length and decrease the length of sides, right? So you don't have to click on the white dots. Just click on the object. Otherwise, just simply click on the object and do not leave the button and drag and drop it from the place you want to have this object. And try not to click on the whites, just click on side of the whites and drag and drop the object. This is how you can rotate the object in the workplane as well as shift the object from one place to another.
Thank you.
Sir, I have one question. Sir?
Yes, ma'am. Please go ahead.
Am I audible?
Yeah, perfectly audible.
Yes, sir. Actually, these 3D designs which we are now preparing, that gives us a simulation and idea of how the real world objects will appear to be.
Yeah.
Right.
Yes.
So if suppose we are designing a particular kind of castle, so when we are changing the dimensions through stretching or putting in the dimensions in the boxes, then we'll get an idea of what the ratio would be when we will pierce a particular shape into it, and we will align, like you aligned a cylinder or a dome shaped onto it. So that will also be helpful, right?
Yes, ma'am. That will also be helpful in this case. So as per my perspective, if I try to design something on this TinkerCAD platform, then I go for the rough sketch in my copy, like what will be the dimension of the sides and what will be the dimension of the hole itself and all the bevels type and sides of it. Then I try to correlate with the scale we usually do have in our pencil box or something. So you can able to come up with the basic consideration, like how this particular object after printing will look like in real world environment. So first of all, I idealized different components, and I took the took the dimension of different components like the motors and ultrasonic sensors. Then I designed the casing for those components and accommodated everything, gave me the proper result of how this object will look like after printing it using the 3D printing system itself.
So that is the basic motive which you were telling earlier when you introduced the TinkerCAD, that it will be cost efficient, right?
Yeah.
So that
Yes.
that is coming up, right?
So that is actually cost efficient because why I mentioned those. Suppose in earlier times when the industry have to manufacture something like this mouse or some of the product, your mobile phone, because they go through the research phase and they go for the design and development, they prototype development, right? They first have to create one sample piece to test it out in real world environment, so that then only they are confirmed that this particular model is working fine and the shape is working fine, and I'm able to hold this mobile phone which I built as a prototype perfectly in my hand. Then I can go for the mass production, because the mass production does require a lot of money in the process, right? That is why the rapid prototyping came into existence, and right now it is giving us the opportunity to visualize the stuff at a lower cost and in less time compared to the complete project development. So you don't have to invest on that. The rapid prototyping is introduced in our system to help us on that.
Yes, yes. Instead of releasing that sample, we can use it open
Yeah.
source, which is actually free. Thank you so much.
Yeah.
So
Yeah.
it will
And
help us to
apart
create,
from
sorry,
yeah,
sir, it will
apart
help us to create a prototype, right, sir, before we go
yes.
into real model. Okay,
Exactly.
got it, sir.
Yeah.
Thank you.
Suppose your student try to made one of the project for the science exhibition contest, or suppose they are participating in World Robotics Championship and they come up with the ideas of like developing something new which is not available in the market. So you teachers can able to help them build the circuitries using the Arduino and other IoT devices and so many microcontrollers and combination of sensors, and then you have to go for the case designing and product designing itself. Then only it will be representable in front of the jury members, right? Otherwise there is no requirement to have those showcasing ideas. Right now the era is going forward in the entrepreneurship, and many more person is coming up with their ideas of product and becoming the entrepreneur of the tomorrow. So what we are doing is to trying to help them have these skills. Like if they know the process, how to develop the project from the scratch to the final level, then they can also able to help themselves in their career ahead. So that is the reason why the STEM and robotics or AI being introduced to the system. Let them have the technical expertise of what industries is having by hiring the engineers and so many people to work with them, right? So apart from this, if I show you one of the example which I printed earlier, let me stop sharing my screen and I'm closing it. Okay, and I'm recording this window. Okay, fine. I'm opening one of the design which I created earlier. The skull ray. That's the complicated design to showcase, but it will worth explaining the process. So if I open it, this design in the Cura software, allow me a second. It is opening actually. So today only we printed this model using our 3D printer in engineering college, not in this school, but I would like to share the insight of how we can able to go for that, the final stage of 3D printing. So after generating the model, what we are left with is this person. So you can see we do have this model design. I designed this model, and if you want to go for the 3D printing, then we chose the printer and set up the each and every instruction in it, and then further we are going to slice this. Slicing means we are generating layer by layer data of these designs, and if you click on the preview, you can see the real-time printing of this skull design, this skull ring design. The layer will be deposited like this fashion, and the complete design will be turned into reality. So this was the idea of implementing the object directly into our prototyping phase so that we can able to see and visualize the thing before it gets print. So we can able to see how it will print and how the layer will look like, because 3D printing works on the layer basis. One by one, each and every layer will be printed to the bed and we will have the final product. So this is the advanced version of what we are trying to do in our classes. But I want to recommend to go for these right now, as you are in the early phase of your classroom program. So it is advisable to have the understanding and knowledge of this platform, which will help you forward in your classes to, like, whatever the student come up with the ideas and the question, you won't lag on that situation. That is the reason I'm trying to mention each and everything throughout this lecture plan. So I hope this session is useful for you, will become useful for all of you teachers out there, and I hope each and every person learned something from this classroom. So, and in case of any doubts, then please help me with your questions so that I can explain those and end this journey for today, so that we can meet up tomorrow. And by the time we meet up tomorrow, you guys can able to go for the designing practice and come up with your design ideas, like what you invested and how you design certain things in TinkerCAD platform. I already shared the classroom link to this chat in this chat so that you can join over to the classroom, and I will create the activity for you all to participate on that, so that it will be great for me to visualize your design as well, so that I can fix the issue and help you maintain the proper learning process in this journey. So any other questions, ma'am and sir, if you do have?
So that all together will come when we'll do hands-on on it, and we'll get to know that how comfortable we are with these practicals.
Okay, this is only for learning of you teachers out there, so that the more time you will invest on these kind of platforms will give you the proper understanding and further can able to help you on the major problematic time in your STEM journey. So I hope this class